Hello, my viewers. My name is still remain with Sunday, and I welcome you all to my YouTube channel on BU Form Academy. This is the academy that work with my own professional experience. Today presentation, I will be looking at how to convert pph of BU Form formulation to kg of the raw materials for box foam production. If you take a look at all my previous lessons, I did say that PU foam production can be done in three methods. Method one is a continuous process. Continuous process is whereby the foam or the raw materials are continuously produced. You understand? Continuously produced by the use of a machine called foaming plant. Okay, that's why they call it continuous process. But semi-continuous process can be subdivided into two. Some part of raw materials are continuously applied to the mixing chamber, while some material are added manually. It's not fully continuous, but continuous is fully automated. Now you look at the batch process. Just the names imply box foam. At times we use it when we are carrying out laboratory scale. At times we also use it for those of us who are entrepreneur in the system. They call it box foam. This is a name commonly used here in Nigeria because I do not know where you are watching me from. We call it a box foam. Now, but looking at the formulation technique is the same. The formulation technique is same, but the conversion factors is different because formulations means they require components of all the raw materials are properly, okay, ratio in respect to the density. In continuous process is kg per minute. In a box foam is in kg because time is not included because continuous process work in respect to time, kg per minute of delivery to the reacting system. Now, looking at this formulation, I did say that in PU foam industry, formulation are designed in part by 100. Okay, 100 in the sense that all other raw materials are depend on this 100. 100 will allow the industrialist, the manufacturer in the industry to carefully scale out the formulation process accurately because this part per 100 is the industrial convention technique that are being used globally. So by designing your formulation in part per 100 will also help you to carry out your costing effectively. Are we all together? And I did say that all the three methods mentioned so far are the same formulation, but how we convert this part per 100 of this formulation to kg is different from that of continuous process. Okay, it could be similar with that of semi-continuous process because it's close to the box foam production. Now, looking at this formulation, there is filler of 20%. Adding filler to a virgin polyol means you have to do it in a substitution manner. So what it means, you remove 20 parts of filler from here. That is polyol was 100, but you want to reduce the cost of the production using this filler. So you replace this and take 20 from here. That will still give you 100. So 80 plus this give you 100. So this is, let's assuming this is the formulation, and this formulation give us a density of 21 kg per meter cube. But this is just for a guiding principle. I do not say apply it in your various places of factory. Before you can work out formulation, you have to have a deep knowledge of function of individual raw materials. Go back to my previous lesson, I've mentioned them. The silicone, the amine, the stannous, the polyol, the TDI, what they do in a particular point. You understand? So these are the formulation of raw materials. And this we assume it is for the density of 21 kg per meter cube. This is the polyol, and this polyol from the raw material safety data sheet, that is the technical data sheet, the manufacturer said, assuming that the number of reactive OH group is 42. So we normally use it to calculate index. And index, looking at index has to do with adding extra TDI from that of 100, calculated from those two formula from my previous lesson. I did say that TDI is consumed in a formulation, is consumed in two ways. The amount that is react with polyol and the amount that is react with water. And in a formulation, the density is being influenced by the blowing agent, that is the MC and the water. So there are some formulation that do not require MC. Those ones are higher density that are used in furniture purposes. You understand? I did say that MC is extremely needed when you are producing a low density. Why? Because you need to blow it much with the influence of the water to achieve that low density. As a result of it, you need a bit index of 116 to 118. In this case, if you do not use MC, the exotherm temperature will increase. So, and much CO2 will be generated. In this CO2, the MC will take the heat from the system to the surrounding environment, because the forming process is exothermic reaction. So look at the formulation parameters. Now look at our TDI, index of 112. And I told you normal index is 100. When it's less than 100, we say excess polyol. When it's above, we say extra. So based on that calculation, we use an index of 112 because we want to increase the hardness of this foam a bit, because it's a medium density that are used in bedding purposes. You can also use for furniture. You can also use for other packaging purposes. But the main objective was a foam of this density is basically used for mattresses. That is, we call it medium density. They are not heavy duty mattresses like that of higher density. The low density specifically used for packaging and also furniture purposes. Now, look at the first. Having done this, now you need to first look at the volume of your mold, because in a box foam you prepare mold. The mold is varies in terms of the size of mattress you want to produce. 6 by 6, 4.5, for example. If it's 4.5 mattress means the mold length would be 75 by 54. Then depending on your height that you want, okay, when you measure this in inches, you then convert it in meter, then you have 3.7. This is just an example. We assuming that this formulation is going to be used in this mold volume of 3.7 meter cube. You understand? So that is what give us this is the length times breadth and the width. Okay, we have m raised to power 3. Now we also have that the density is 21. Okay, this formulation is what we call desired density and calculated density. Desired density means what you proposed to carry out, and when carry out a formulation, the first thing that will come to your mind is that what density do I want to produce? If you answer that question, what hardness do I want? In terms of hardness, you are going to choose your TDI index that will harden the foam, whether you use water blown formulation or water and MC formulation. It's all depending on your process condition. But you may decide to use MC and water or only water alone. If your formulation is right, we are going to achieve the same density. But the property may be different depending on what your customer wants, whether it is to be soft or it's to be hard. So it's all depend on what they want. So looking at this, sorry, this is the density. Now we want to calculate the the total mass of the raw material that will take this volume of that mole to a certain height. You know, in terms of this, we have added the height. The height here, let assuming you need 44 heights. Okay, so you have them in this calculation. Let assuming this is what we achieve. So density times this times 3.7 meter cube. So meter cube, sorry, this one will take this one away, we left with kg. So 21 times 3.7 will give us 78 kg. Now in this 78 kg, you have to add 3%. The reason for 3%, we call it overweight. You know, when you have a raw material in a mixing bucket for box foam, okay, by the time you add, after adding all the necessary raw material, so the TDI will come last. What you add TDI with continuous mixing before you then discharge all the raw material to the mold that you have already prepared for that production. Okay, not all the quantity that will effectively discharge from that bucket. So the remaining or the leftover account for 3%. Now the gas loss. Looking at the gas loss is generated by the reaction of water and that of MC. So we have calculated it by part of water times 2.44, okay, plus 7.1 divided by 7. Add this to this. Whatever you have here, you now multiply by 0.8. That the gas loss when 1 mole of this is used. So the total gives us 7.5. Now you now add all your formulation ingredient in parts. Okay, that gives us 154.58. Then we now minus it from there. We have this. Now we want to calculate the multiplying factor. The multiplying factor means a factor that you are going to use to multiply all the part by weight of your formulation and ingredient to give you in kg that you are going to use in your box foam in respect to your mold volume, because this mold volume is not fixed, it varies depending on the size. So once the mold volume increases, the kg, the amount of kg will increases, but the part, your formulation in pph remain fixed. The kg will increases in respect to what? The molar volume, provided that the density is the same. But if the density change, the mold volume change, the formulation in part per 100 will also change. But if it is fixed, the density is same, the mold volume changes. Only the kg will also, the kg of the formulation raw materials will also change. Now, multiplying factor means, sorry, 83. When you divide 83 by this, will give you 0.4, 0.54, sorry, 0.54. This 0.54 is our multiplying factor. Okay, this is our multiplying factor. This multiplying factor, you are going to use this number to multiply all this. Okay, you use it to multiply all this. We have this all. So in this case, this is what you are going to measure. How do you measure? Put your mixing bucket on a weighing scale, tell it remove the empty weight of that container, measure polyol 43.2 first, Next, you add 10.8 kg of filler. After, you add 1.13 of MC. This one you convert it to grams. This one you'll be using, all these ones are called catalysts. So you can use a small scale so that you achieve what we call accurate measurement with these decimals places. Okay. When you add all this raw material, you keep mixing it. For you to have what we call a foam yield, you have to mix your formulation or raw material very, very well. The more the mixing is the more you mix it well, the more your foam will rise effectively and release the healthy gas. But if you do not mix it very well, you will not have the required height expected. Reason in that, you are adding calcium here. Calcium reduce what they call reaction time. That is the reason, because we use calcium 20%, you have to rest your blowing agent and keep the density at this 21. Okay. So what I'm trying to say there, if you are using 20%, the more you are increasing your calcium in your formulation just to manage the costing, you need to step down your density by 1.5 or 2 as expected. Like this one, we have in mind to make 21, but we'll be targeting 20 density. But by the time you are adding feeder, because this is adding extra weight to the virgin polyol, the density will increase to 21 as calculated density. So this is how it's been done. Okay, you have to mix it well. Now, looking at this is how you'll be able to carry out your costing. For batch process, you cost your foam based on a kg, okay, based on kg, but you have to calculate what they call cost per kg. So when your foam dry, you open it, take the whole block, put in a weighing balance, the kg, okay. The unit cost per kg multiplied by the weight of that foam will give you the total cost of that foam or block. Then you add whatever you have, maybe the administrative charges or overhead, you now have the total cost. So this is how box foam is being used. But please do not apply this. Get trained, understand it. If you do not understand it, then seek knowledge for proper guidance. This is just the guide so that you will not get your factory born and blend Ekpenyong Nwesope Youth Foam or YouTuber Academy. So you have to train, or you ask question. I will answer you to see how you can effectively optimize your production using a batch process. I hope this is very, very interesting. I have a lot to tell you about the subject about box foam, how you can optimize your production or efficiency, optimize your profit, and reduce your cost. Okay. So what you need to do is to like my page on your notification bell so that whenever I release a new video, you'll be notified. Subscription is free. Keep sharing and subscribe so that you gain more knowledge that will help you in your production or process and technique. Thank you. Bye bye.